simplest example I can include in the slide, so that you can see the step by step how the drawing can be done. Okay, is it okay? All this is just the theory things. It means we transform the cause effect graph into the decision table. We list down all the causes and the effect, and then we will write the value. So I leave it to you. Either you want to use true false, or you want to use the 1 0, or you want to use the yes no. But I don't really prefer to use yes no, but if you want to use can, no problem. Like this one, they use actually yes no, this example, this one. Okay, y is for yes or true or 1, and is for no or false or 0. Okay, is it okay, this one? Before we check another example for this ATM, which is a bit more things to show. Is it okay? The cause effect graph and the decision table. So we will do in our tutorial and also our practical. I have a set of questions for that. So no worries. Okay. So far, okay. Can understand how the technique work. So this one is nothing to do with the minimum maximum. There is no range of data here. Okay, we don't have borders, we don't have minimum maximum range or nothing. Okay, so here it's more to condition and what will be the action or the causes and what will be the effect. So for this effect to be true, we don't test when the effect is false, we don't test the false part, we only test the true part. It means when this effect happen, our focus is to check the test must prove the effect is happen. So we don't do the test to prove the false part. No, we want to prove that the file is successfully updated, when it will happen. We want to prove when the message X will be printed, when the message Y will be printed. So our effect here must be always true. They can never be false to prove the false thing. Okay, so that's why the effect I prefer to put the dash on the part we don't use, so that you can see we only want to prove the false part. I sorry, the true part. Nothing to do with the false part. Okay, got it? Can understand? Okay, so let's see. This is another example. This is for the ATM. Okay, so these are the causes. Okay, and these are the effects or the action. So when a bank card can be rejected, when the machine will ask for new pin, when the machine can eat the card, okay, and then when the machine asks new amount, and when the machine will pay money. Okay, so these are the list of effects. Okay, then let's see what are the causes. Bank card is valid, pin is correct, third pin input, and money available. So let's see for each of the effect how will be the causes. So when the card will be rejected by the machine, when this will happen, what does that mean? What does this mean? If we have the causes say that bank card is valid, and when we use this, what does that mean? When we use the not, what is that mean? Invalid. Okay, so the ATM machine will reject the card when the bank card is invalid. But our course here written as bank card is valid. So we need to use the not symbol to make it on the opposite way. So when we use the not, it means the bank card is invalid. Then this cause will happen. Sorry, this effect will happen. Okay. So let's see the second one. Ask new pin. When it will ask for new pin. Okay. Bank card must be valid and pin is correct. But see here, pin is incorrect. And what is this mean? Here is third pin input. And if I said not, what is that mean? Have I entered the third input pin? Have I already entered the third pin? If I put invalid, if I put not here, what's that mean? And all this need to check together and it's using and. It means it must happen together. It means when the bank card is valid, when the pin is incorrect, and when we did not input third pin. That is what it's mean. Third pin input. When we put not, it means we did not put third pin yet. It's still one or two. That is when it will ask for new pin. Okay, and when we put this n, it means our test case will be one test case and it will test these three causes where the first one is true, this one false, this one false. Okay, let's see the third one. When the ATM machine will eat card, when the bank card is valid, when the pin is incorrect. The second one, when the pin is incorrect, and can you see here, when we already enter third pin input. Third pin means third time. First time, second time, third time. So when all this happen together, then the machine will eat the card. So it will be true, false, and true. Okay, then the next one is when the machine will ask for new amount. When the bank card is valid, when the pin is correct, do we need to have anything about the third pin? Can you see there's no line going, because we did not have any trouble of entering the pin. So the pin is correct and money is not available. Can you see? Here is money available, and when we use not, it means when money is not available. When all this happen, it means true, true, false, then it will ask for new amount. Okay. Then the last effect, pay money. When the ATM card will pay money, when the bank card is valid, when the PIN is correct, and when the money is available. So all these three must happen together, then the machine will pay the money. So if you see, do we have any or situation here? Do we have any or logic being used here? It means either this or this. Do we have such situation here? No, all is using and. This one is only one, but the combined one, all is using and. Okay, so let's see how the table. Okay, so these are the list of condition. These are the list of the action. Okay, where is it? Okay, this one. So these are the effect: reject card, ask for new pin, eat card, ask for new amount and pay cash. So the condition is bank card valid. So here the decision table, they did not use labeling like the example just now. They don't have the C1, C2, E1, E2. So they put the whole statement inside. I don't really prefer this way because it will be mess up your graph and also your decision table. So it's better for you to list down everything on the top and then you use the labeling part C1, C2, E1, E2. It will be much more clear to see your work. Okay. So they ask like a question form because they use yes, no. So bank card valid, pin correct. It means like a question. Third pin attempt, money available. Okay. So if you see, this is what we want to test. The yes part is what we want to test, not the no. Okay. So when the reject card happen, when the bank card is not valid. Can you see? They use N instead of Y. It means on the opposite of Y, it is not. Okay. So when the bank card is not valid. So when it will ask for new PIN, when the bank card is valid, when the PIN is not correct, and when we did not attempt the third time. So this will be the second one. Ask for new PIN. When the when the ATM will eat the card, when the bank card is valid, when the PIN is not correct, and we have attempt the third time. Okay. Then the machine asks for new amount when the bank card is valid, when the pin is correct. Since we did not test anything for the third attempt, right, we put the dash. And then when the money is not available, so this will be when it will ask for new amount. And the last one, the machine will pay the cash when bank card is valid, pin is correct. So this one we did not test, and money is available. So can you see? We don't have any or situation. So based on the graph, we can see one test case per effect. So this one, 2, 3, 4, 5. So since we don't have all situation, so we have exact 1, 2, 3, 4, 5 test case. Okay, got it? Can understand how the cause effect graph and the decision table work? Okay, is it okay? Can I? It's just a simple thing. It's just that we need to understand the requirement, and then from there we translate into the cause effect graph and your decision table. What you do in the cause effect graph, that's what you will transfer to your decision table. So they work together. So your decision table must be tally with your cause effect graph. If your decision table is not tally, then you will lose mark because your decision table is not standalone. It's coming from the cause effect graph. Okay, can so the last part is the pairwise testing. So this is what I said. We will not cover in any of it, but it is actually one of the logic based testing technique also. And this one is actually more to UI element, because our assignment, our midterm, our final exam, we don't really play around with UI much. Okay, where the pairwise testing is actually combining the UI element for them to identify the number of test cases. Okay, so actually here the example of the scenario show us how we can reduce the number of test cases. It means the combination of positive and negative test cases by using the pairwise, how we can pair them wisely. Okay, so this is the scenario given. Okay, so the scenario here is, if you see, they have like a different type of elements. Okay, so this is the simplified version of those elements, where we have a list box, we have a checkbox, radio button, and the text box. So list box means this will be the values inside the list, 0 until 9. Checkbox means it will be allowed to do the check and uncheck. Then radio button is on and off. And then text box to accept any value between 1 to 100. Okay, so this is the UI. So before we use the pairwise testing, so this will actually give a exhaustive combination. Okay, let's see here. The list box total of 10 different input, checkbox 2 different input, radio button 2 different input, and the text box can receive 100 different input. 100 different means start from 1 to 100. Okay, so if you see using the Cartesian method, okay, how we can product them, what will happen is this will be the total number of test case, which is total of 4,000 test case based on the product of these four elements and based on the number of input. Okay, this is just valid test case. And how about negative test case? It means when we are using invalid, so it should be more than 4,000 test cases. This is using the exhaustive combination. Okay, so now how we can bring them down? It means from more than 4,000 test cases, we want to bring them down. So what we can use is the conventional software testing technique, where the list box, we actually select 0, which is neither positive or negative, and then we have others, which is the value from 1 to 9. Then for radio button and the checkbox, we have only two combination, which is on and off. It means check or uncheck. Okay, then the text box, we can separate into three different input, which is the valid, invalid, and any alpha special characters. Okay, so from 100, now we use like the equivalent classes, right, to separate them into valid, into invalid, and into a special character. So what happened is, from here we have two, we have two, and we sorry, this one 2 and this one 2, because we have radio button 2, checkbox 2, and then we have 3 here. So now from more than 4,000 test cases, we can bring it down to 24 test cases, include the negative. Okay, because we also cover the invalid part. So this is using the conventional software testing technique. So now this is actually still high. Consider 24 test cases for just a simple UI. It's still high. Okay, so this is how it will look alike. Based on the value given, they bring a table here. So the text box, we have valid input, invalid input, and then alpha special character. Then for each of them, we combine them with the list box, which is the two values, 0 others, 0 others, 0 others, and here the checkbox is checked, unchecked, and radio button is on, off. Okay, so what happened here is this is how we can combine them to get the 24 test cases. So if you see from exhaustive combination just now, which was more than 4,000 test cases, include positive and negative. Using the conventional software testing technique, we can bring it down to 24 test cases, and by using the pairwise software testing technique, we can actually bring them down to 6 test cases. Okay, it means we get these 6 test cases: 1, 2, 3, 4, 5, and 6. Okay, so this is actually about the pairwise testing. So I don't access this in any. Okay, not in any, even for assignment, even though we actually mm, sorry, I think it's a mistake. This is supposed should be in our chapter 3, right? We already discussed the experience based testing, right? Sorry, we already discussed this, right? The experience based testing. Sorry, I think it's supposed should be wrongly placed here. Should be in chapter 3. Okay. I will update back the slide, then I will share again in the Google Classroom. I think I wrongly edited. Okay, so our chapter 4 is until here. Done with the design technique part. Okay, got it? Can understand? So the important is the two pairs. Okay, equivalence partitioning and boundary value analysis, and under the logic base we only take the pair of cause effect graph and the decision table. Done. This is the important one. So as what I have mentioned, for your assignment you need to choose which pair is suitable for your functionalities for your module, and for midterm I will use one pair of them, and what I have used in midterm I will not use in final exam. So it means I cover each of the pair in midterm and in final exam. Okay, any question? I'm done with chapter 4. Any question? All okay? You have class with Mr. Lim today, right? Mr. Lim is already back, right? From leave? Because I did not contact him at all after last week. Okay. Okay, so any question? So next, when we are meeting, okay, Wednesday for our tutorial, we will I think we're still pending on tutorial 3, some of the questions. So once done, then we will discuss tutorial 4. Okay, so if there is no question, then I'm done. Thank you guys. I don't want to hold you for long. So thank you very much. I'll see you on Wednesday.